Many individuals fantasize about going through space and maybe even experiencing extraterrestrial life. Proof for higher living things is lacking, despite the fact that single-celled creatures are possible. Organisms, microorganisms, and infections have taken up home on the International Space Station, ISS, and are getting along shockingly well. However, microorganisms follow humans, not the other way around. The reason for life as we know it is liquid water. Ultimately, we humans are comprised of 80 to 85% water. We need to drink around 2 liters every day. An existence without liquid water is barely possible. Indeed, even single-celled life forms generally swim in water. Viruses don't necessarily require water, but they only exist where there are life forms they can infect. Thus, viruses are also indirectly dependent on liquid water. But do the stars hold water at all? Unlike the Earth, our Moon and other planets have an exceptionally difficult time with liquid water. The Moon is no exception. Now you can find out why. If you like our videos, go ahead and support us with approval, subscribe, and prepare for many additional fascinating videos in the future. Music. The Moon, the first extraterrestrial destination, filled with ice. Johannes Kepler contemplated an excursion to the Moon as early as the 16th century. This brilliant man, born in 1571, was not just a cosmologist, mathematician, and physicist. He also enjoyed philosophizing about nature and believed the sun to be the center that defeats the inertia of the planets and forces them into orbits. That being said, he pondered gravity without knowing the concept existed. He believed that it would be hard to leave Earth to go to the Moon. Most of the way there, the journey would become easier. He also concluded that, after 400 years, going to the Moon was almost old hat. But, in fact, there had already been 8 people on the Moon, out of a total of 12 so far. In 1969, the first crew was launched into orbit in a lunar rocket. Translunar injection is the name of the move in which the rocket escapes Earth's gravity. By firing again until most of the way there, it is captured by the Moon's gravity and plunges towards it, making the journey much easier. On July 21, 1969, Neil Armstrong became the first man to go to the Moon, opening a new chapter for humankind. One small step for a man, one giant leap for mankind. However, the first 12 visitors to the Moon also found that, despite the brilliant views of Earth, there were mostly rocks there. That there could be water there seemed impossible. After 40 years, however, water was detected in the rock samples brought back from the Moon. In the meantime, even large amounts of ice are thought to be deep in the lunar craters. But liquid water doesn't exist on the Moon. The Earth, the main area for us humans and filled with liquid water, was what the first astronauts said, "We went to the Moon, but we actually found Earth." The perspective of Earth from the Moon, in fact, is possibly one of the most important images that changed thinking in the 20th century. To be outside looking down at Earth is a mind-bending experience. We saw it and rediscovered it, but interest in going to the Moon declined because humanity had already done it. Furthermore, no one really knew how to use the Moon for humanity. Again, people saw exactly what it cost to put humans on the Moon. It was essentially too expensive. Keeping Earth clean and livable became the priority, where it still is. Mars, our closest neighbor, humanity's dreams turned more toward Mars after that. The red planet is the 4th from the Sun and, thus, our outermost closest neighbor. Humankind has been dreaming seriously of an excursion to Mars since the first humans set foot on the Moon. However, it is notable that the preparation of these dreams has not happened as expected in 30 years, despite what we thought. Nevertheless, many tests have already been conducted on the planet regarding a trip to Mars. A psychological trial completed a few years ago was designed to show how people react when they are confined in a small space for long periods of time, likely how long it would take to go there and back. It would depend a lot on where Mars was relative to Earth. Unfortunately, the ideal time for a Mars mission with the shortest journey passed a few years ago. Mars is coming back, but it will take some time. The distance between Earth and Mars is expected to decrease a bit in the next 25,000 years. This has no practical significance for the Mars venture, but it will still require many years. Hypothetically, Mars colonization is now technically possible, but it would take a bit more than a few drops of water. Music. Venus, our closest neighbor with minimal water vapor. Venus, the second planet, is actually our closest neighbor and our inner direct neighbor, a mere 25 million miles away, 10 million miles closer than Mars. However, humanity has become more and more intrigued by Mars. It wasn't because they knew Venus is extremely hot and water would evaporate there. Studies show that the dry planet of today has a water-rich past. Water vapor occurs in small amounts in the atmosphere. The fact that the solar wind has stripped Venus of its water is evident. Mars and its water supplies. What about water on Mars? Why can't there be liquid water on the Moon? Why is water evaporating on Venus? Does Mars have the same issue among other things? It has to do with the atmosphere. The Moon has no atmosphere, and thus liquid water would evaporate into space. Venus has a thin atmosphere that can't hold water either. Mars' atmosphere is a CO2 environment, but it also contains some water vapor. Once again, this makes it believed that the Martian climate is too thin for liquid water to exist on the planet's surface for any length of time. Explorations of the planet are similar. Water vapor in the atmosphere, ice inside the planet. But liquid water on the planet's surface is unlikely to exist. Still, the web is full of reports about liquid water on Mars, dark streaks, Mars streams of water, or simply dust. In 2010, momentary dark streaks were first detected on Mars. Based on the development of these streaks, they appeared to grow longer and then vanish during the warmer season. They were thought to be water running down Martian slopes. In 2015, it was reported they might be saltwater, allegedly perchlorates, which lowered the freezing point of water, like our antifreeze. In 2017, however, the same streaks were rethought as dust flows after being seen with an improved camera. Underneath the surface of Mars, Martian lakes. In 2018, scientists described a large lake under the red planet's south pole. The radar of the Mars Express, a European robotic spacecraft orbiting Mars, is responsible for this discovery. It is based on indirect observation, the reflection of radio waves. In 2020, 3 more such lakes were described. The lakes, which are said to extend over 46,000 miles, are speculated to consist of saltwater. And what do you think? Few things are as exciting and simultaneously as fundamental as space exploration. The decision to initially focus on robotic spaceflight was the right one. Nobody wanted to risk losing humans up there. Letting robots and machines take the initial steps in revealing what's really going on up there was wise and practical. The first lunar voyagers also knew, at least from previous tests, what to expect. Generally, a trip to the Moon would likely have meant a death sentence without much additional knowledge. Moreover, humanity would have lost its desire for space travel. However, indirect observations remain indirect observations. While theoretical knowledge is significant, if various cameras can mistake the same object for liquid water and dust, then the interpretation of observations, especially on Mars' surface, is still extremely important. And if radar is used to describe a structure beneath Mars, then you're literally walking on even thinner ice. Can we truly rule out the possibility that Mars' saltwater lakes won't be mistaken for its coal reserves tomorrow? Liquid water on Mars and other planets is a tremendously exciting topic. However, it will likely only be established more firmly once the first samples can be directly inspected on the planet. And if you're waiting for the first Martian settlers to visit the first underground saltwater pool, you'll have to wait a few more hundred years. The colonization of Mars is still very much a future dream, just like the journey to the Moon was for astronomer Johannes Kepler. But one day it will happen. Until then, it's hugely exciting to follow the reports from NASA and ESA, dream a little, and also form a critical judgment. So what do you think? We invite you to submit comments below.